Very good. There we are recording, we are live. Welcome everybody. This is Kubernetes SIG API Machinery bi-weekly meeting. Today is July 26, 2023. And we have a nice agenda. We had to cancel the last two meetings, so I apologize for that. I think, in the last 5 years, we never canceled two in a row. So this might be, unprecedented, but we will try to not repeat it. So why don't we start with Shane? Shane, are you there? I don't know if Shane is there. So we can give some time to Shane and move to Marek, who has been patiently waited for like a month to talk about this topic. So Marek, it's all yours.
Yeah, thanks. Thanks, Federico. So I wanted to bring to you the topic of changes that are happening in etcd, which are, I think, pretty relevant and coming to somewhat close to scope of SIG API Machinery. So around a month ago, there was early agreement about creation of SIG etcd. And today we are on stage of, we are just getting through the details of things that will apply or will not apply and what exceptions SIG etcd will need. But at the end, there is high level agreement. We need just final confirmation from steering on the details. And so high level, this is not about donating etcd, nor changing the project goals. It's about utilizing the experience, infrastructure, and processes built by Kubernetes. And for etcd to still maintain its own goals and serve both Kubernetes and its own users. We recently did a user survey, and we are trying to get through all the use cases. But high level, we just need more support. etcd is a critical component that needs support that currently we cannot get in CNCF, and we want to collaborate closer with Kubernetes and also SIG API Machinery. So one of the things that were brought up was how etcd can protect its own, like how we can maintain etcd as its own thing when it's part of Kubernetes. So to do that, I have brought down two things. I put them into one doc for clarity, but first, defining our goals as a SIG, and second, defining vision, how to execute on those goals. So high level, we want to build we want to continue supporting Kubernetes as the place to store infrastructure configuration like Kubernetes does. But Kubernetes or API server built a lot of things like watch cache and reconciliation loop that are really great and are underappreciated and not available outside of Kubernetes. And those things are not something that are like inherent to Kubernetes. A lot of current limitations is due to that. And high level, what we want to deliver is on 4 points, like etcd still being the most reliable store, etcd being simpler to operate, but also etcd being as a standalone solution. So part of my work will be, or what I want to do is defining the interface and getting, if you read the implicit contract that me and Joe and Han wrote, we are getting closer and closer with defining the contract and making it simple, because I think there is a lot of benefit from the cooperation. And one of those examples is building the contract, exactly because we found and we are still finding bugs like on how Kubernetes uses etcd, and also a lot of inefficiencies. So my current interest is like making etcd, creating the contract, optimizing the contract, and making it available for everyone. And like to put like a cherry on top, we want to scale beyond Kubernetes, because API machinery is great, like scheduling pods is great, or like running Kubernetes, but we want to go further. Like there is now more movement in batch area. There is more movement in like multi-cluster control plane. etcd should be able to give that. We just need to work together. So I bring those topics and those ideas to you to get your feedback, get your ideas, and maybe inspire you to work together towards this vision. I put on top, like additional in the document, I put the interface that I'm working on that we have already agreement with Joe, or like SIG leads, about having this interface on etcd, so defining interface between Kubernetes and etcd and putting it, but we will put it on etcd side because this is part of etcd reconcile. We want to put reconcile or how Kubernetes uses and the interface exactly in etcd, but not and keep it there. Yeah. So that's all from me. Open to questions or like feedback.
See, Jago has a hint.
Merrick, this is awesome. Thank you for putting this together. My question is about etcd 3.4 to 3.5 and either of those to 3.6. And I haven't seen it be explicitly called out as a goal of the working group to ensure that this is a safe path for Kubernetes users, but I would like to if it isn't. Is that something you discussed and decided not to include, or is that something we could add?
Yes, this is like high level vision. Recently, we added a roadmap for what we want to deliver to for 3.6. It's like the scope for delivering what we want to, or the scope was mostly defined like last year. We are just getting really slow on getting there. And there is recently, if you go into the main repository, there is in documentation now the roadmap file. So we have a roadmap that lists all the tasks that we want to go through. Based on our current maintainers capacity. Like,
is the upgrade path from 3.4 to 3.6, would that be worth including in like the scope for 3.6? I don't know enough to know if that is okay already or if that's something that needs agreement.
I'm not sure I understand like upgrade path. Do you mean upgrade downgrades, or do you mean?
I think just building on my initial comment, which I think Jordan is riffing on, is my understanding is there are issues in 3.5 that are known to be dangerous, and so we are cautious in many cases about choosing 3.5 today. What I'm not clear on is if we intend to fix those issues and 3.5 is an expected step between 3.4 and 3.6, or if we expect Kubernetes users to go from 3.4 to 3.6 and skip 3.5 or something else.
Yeah.
But if I don't expect that would be something specifically in the etcd project, and I want to make sure that the Kubernetes working group has this in scope as a thing to keep in mind.
Okay, now I think I understand. Okay.
There is a hand from Han.
Yeah. Yeah. So I actually just had a conversation about this with Merrick like 3 hours ago. And basically, I would like to push for a downgrade path from 3.5 to 3.4 so that we can upgrade safe, like, and have some sort of option to roll back, right? Like, given the issues with 3.5, I think that is a necessary requirement for us to be able to do that.
No, is that because of the experience we had where 3.5 did have a problem and we did not have a downgrade path to handle it?
Yes.
Or is
yes.
that because I'm not actually aware of an etcd integrity problem? Is there currently an etcd data integrity problem?
I mean, there has been so many in 3.5 that we are a bit reticent to upgrade to it without some backup plan.
Okay, but there is not, like right now, known a data integrity problem. It is fear of an unknown, which, I mean, I won't dispute whether that's valid or not, but
yeah,
we don't actually know of anything, right?
There
Yeah.
was some major refactorings that went on between 3.5 and 3.4, between 3.4 and 3.5.
So
I mean,
there is not a known issue with 3.5, but we are not certain about 3.5 as an intermediate step. Is that a good summary?
to clarify, to get everyone on the same page, we had issues last year.
Yep.
Well, we found, like, we built a whole framework to track and find those issues. We found issues in 3.5 that reproduced all the reports that we had, and we are consistently testing it. And we even found issues with 3.4. What we didn't find is there are still open Jepsen reports on 3.5, but we are unable to reproduce it. Reason is we don't have experts in Clojure. Like, we don't, and the author of Jepsen is totally not available. So we cannot reproduce. I mean, if someone wants to look into that, that would be great, but we cannot reproduce them. So we keep them open and look at them from time to time, but no one was able to verify them. So to answer, is there any unknown to 3.5? Yes, there is unknown with Jepsen reports.
So I guess question to Jago, do you see the acceptance of the SIG as predicated on whether or not they agree to do this, or is it a independent of whether an etcd SIG is created, this would be desired to put on a list?
I'm in favor. Well, is it a SIG or a working group? Either way.
It's a SIG because it's going to own code.
Okay. I am in favor of the Kubernetes project directly investing in etcd as a hard dependency. And I'm suggesting that this specific idea be added to its charter or roadmap or things that it keeps an eye on.
Okay, but it's not predicated on that.
No, I think it's not blocking. It was I didn't see this. It would be great to see that suggestion.
Yeah, I agree. I would like the option of a downgrade as well, but I also would not predicate the decision on it.
To just finish, we have downgrades implemented for 3.6. We are just discussing and driving agreements to backport it to 3.5. And when it gets into 3.5, it will support downgrades from 3.5 to 3.4. So that's, I think we are getting closer to agree on that, and this is on roadmap. Like, there is a link to issue now documentation at roadmap that you can see. I mean, I have now on the screen, and that includes backport. That includes downgrade support.
I think I'm sharing, Marek, in case you thought you were sharing, but this is the kind of the planning board with the roadmap, right?
There is a separate issue on that was on your side.
Yeah, I opened
here
Kubernetes.
Just before here, or
this one.
Like, it's not plans for 3.6 because we want to. This is backport.
Okay.
So you will not find it under 3.6 milestones. You will find that just like there is a link here. No, okay. I can paste you up later.
Okay, I just opened it. Thank you.
Yeah, I don't want to take more time, so yeah, feel free to contact me if you have any feedback, or come to our community meetings.
Oh, Merrick, this is really great. So I've been tracking this. I'm really happy to see this going through. Did you have anything that you were missing or needed from the SIG, or any other meetings you need leads to attend?
No, I think we are just discussing it
Okay.
with Sturing now.
Yeah, grab us anytime if you see something that we might need to attend or anything like that.
Yeah, sounds good.
Very good. Any more questions on this topic? No? Okay, very good. Thank you, Marek, and everybody participating in this. I pinged Shane, but I don't think he's going to be able to make it today. So let's move to Ben, who I see on the call, and discuss his topic.
Sure.
Hi,
Hi, everyone.
Ben.
So I'm interested in reviving the topic of binary encodings for custom resources, that is APIs defined by CRDs. So right, the context, it's not a new idea. The entry native types have compile-time generated protobuf encodings. These are performant, but they're not something we can just adopt for CRDs because users are defining the structure of these APIs at runtime. So I think a couple of years ago, at least that's the latest work in this space I can find, Joe had done a nice survey, sort of taxonomy of a few different options for various encodings, and also gone pretty deep on how we might support a protobuf encoding. But so I'm sort of taking it from there. I've done some prototyping work, and one of the key issues with moving forward with this is the specific encoding that we select to move forward with has broad implications on what sort of architectural machinery is required to actually implement and support the encoding. Right, so I see Joe's slides shared now. There's a taxonomy on the second slide, basically between the up one. Yep. So basically, there's a class of binary encodings that are self-describing, just like JSON is. So they basically allow us to have better efficiency and potentially slightly smaller encodings. But because they're self-describing, every time you encode an object, you're going to be serializing, all of the keys in your objects, for example. So that's not an insignificant portion of overhead. And on the other hand, there's schema-driven encodings. Theoretically, these allow us to encode CRs to smaller sizes in terms of number of bytes with good performance because we have a schema in hand that allows us to translate values that we're reading out of bytes to whatever field they belong to on the CR. So by having a schema, we potentially avoid a lot of overhead. But as I mentioned earlier, if we do go with a schema-driven encoding, along with that comes machinery to support persisting schemas or potentially managing the evolution of CRD schemas. So in order to get this rolling, I prototyped various encodings with an eye to benchmarking, so that we can sort of start to consider the actual performance characteristics of these encodings and use that information to decide, do we want to, is it worth it for us to to take on schema management in order to potentially have a more efficient encoding.
What do you need me to put on the screen? Something from the document?
I have a doc,
Okay.
Google Doc linked in the agenda.
Is this?
Yes.
Okay.
Thank you. So I've included 2 existing serializers here. One is just the unstructured JSON serializer. This is what we're using today. This sort of represents our status quo, and anything we select has to be an improvement on this. Otherwise, it's not clear why we'd want to. I've also included protobuf, the generated protobuf serializer here. I think it provides sort of a point of reference on maybe the best case we could practically achieve with a dynamic implementation. The built-in protobuf serializer, of course, also benefits from operating on, typed Go objects and having pre-generated code, which is something that we won't be able to do necessarily with CR encodings. So on top of those, I investigated 3 encoding schemes. CBOR, which is a self-describing encoding. So we would not have to manage schemas if we used an encoding that is self-describing. I compared 2 different publicly available CBOR libraries. And also two serializers that require schemas. So first is dynamic PB. This was mentioned in Joe's work from a couple of years ago. The V2 of the mainstream protobuf library supports reading protobuf definitions at runtime and generating reflective objects that can have their fields populated and could be marshaled and unmarshaled at runtime without codegen. Yeah, I was hopeful that this would perform well, but one problem with this, with using this library directly, is we're operating on unstructured types, right? So map of string to interface slice, and such. So using dynamic PB requires us to convert from unstructured types to take an unstructured type and populate the fields of a dynamic protobuf message, and vice versa in the other direction. So this comes with a lot of overhead. I don't think it's a theoretical limitation of protobuf the wire encoding, but I think it would be hard for us to adopt dynamic PB in its current state and have that be performant due to that overhead. So because of this, I evaluated a second schema-based encoding that's Apache Avro. So I prototyped a little bit of code that generates an Avro schema from OpenAPI definitions. And there happened to be LinkedIn has a Avro library in Go that is designed to operate directly on roughly the same types that unstructured objects can contain. So it has sort of mechanical sympathy with our use case. I think the performance of the Avro serializer is reflective of roughly any schema-based encoding. Is probably going to be in that ballpark. And in fact, we see that the serialized object size comes down to roughly the same as the generated protobuf serializer produces for the same type. But it is not as fast. And it's not clear how much faster that could be with effort focused towards specific optimizations to our use case. But it is probably possible to make that perform better. So I was sort of impressed in the course of collecting this information that at least one of the CBOR implementations performed quite well. Other than the encoded size, the encode time actually outperforms the schema-based Avro. The decode performance is not as good, but it is still an improvement over unstructured JSON. So I think we certainly could today just take a CBOR implementation off the shelf and drop it in, and we would relatively easily see improvements there. I think my decision point now is if we have the option to benefit immediately from a trivial, nearly trivial replacement for JSON serialization, what do we need to prove that? Sorry, how do we make the decision to go with that versus to invest further in optimizing a schema-full encoding? So I'd like to hear thoughts on what we're looking for to make this decision. I think that's effectively my spiel.
Yeah, see, Joe's got a hand.
Yeah, so thanks for doing this, Ben. This is like a really great continuation of stuff that we dropped a long time ago. I do think I agree. I'd always been worried that the dynamic protobuf would be a little underwhelming. These numbers confirm it was actually even a little worse than I thought. I think like the fundamental decision is if we pick something, we're probably not going to do two things, right? We would probably like, if we did CBOR, that would probably be kind of it. It's kind of hard to imagine like doing CBOR and Avro. And so if we did pick, say, CBOR, we would presumably get a pretty significant encode decode boost. And I'm guessing that you could probably even optimize this a little more. But then we would kind of forever give up on the data storage benefit, right? Like we would be kind of pretty much saying like we chose to bias towards the simplicity of just another protocol that is kind of like doesn't require any extra schema information. It's just a substitute for JSON, and then we're picking that, but we'll never really get a storage benefit from that. And so I was kind of curious if anybody had any objections with that. I'm actually much more concerned with the encode decode speed personally, so I don't see it as a huge problem, but I was curious if anybody had concerns about that.
I am also biased towards encode, particularly encode speed. I believe we encode significantly more than we decode because of the watch cache. I'm interested in the speed there and the memory utilization there. The actual storage size has not been that much of a practical issue, in that most people who hit limits on what we can store they want something so much theoretically larger that it doesn't matter. Like if we manage to save 50% on our storage, it won't matter to someone who says, but I want to stick 100 megs in here. Like it just won't matter. And anyone who doesn't really care is already below the limit. I saw Jordan come off mute to hopefully agree with me, but maybe disagree.
Yeah, or their size is dominated by like string content, which is not going to necessarily be helped that much. I agree.
My brain went to the same direction, which is people that are using up a lot of space typically are not filling it just with all the keys, and so they actually don't see as much of a benefit.
Are there hands? No, there aren't hands. It might be helpful to add a few dimensions to the different options which were considered, like making it clear which ones are schema based and which ones are self-describing, and then also making it clear which ones are implementing a specification versus which ones, like the implementation is the specification. So CBOR particularly has an actual RFC standard, and these are like 2 implementations of that standard, which appeals to me. And then we can look at things like how stable has that specification been over time? How confident are we that the spec is stable? And then how certain are we that these things are conformant to the spec in terms of test coverage, improving correctness? The CBOR implementation, the first one, I find the performance very compelling. And so I'm immediately thinking, like, if we could get that performance, that'd be awesome. Now let's talk about correctness and like how confident are we in the things we're writing and reading and the edge cases we know about around JSON handling. Like, how does this thing handle those?
I remember many years ago, I did go look at CBOR, BSON, BJSON, and I think a couple others. And the one thing it's been a long time, so bear with me. The one thing I do remember very specifically is that CBOR was the only one that was very, very clear and precise in what the protocol was. Everything else, there was some place where I felt like it was getting pretty hand wavy and I wasn't really sure what the spec was. But CBOR, you could read the spec, you could understand it. I felt like anybody that implemented it, if they just walked through the RFC, like it told them exactly what to do. Now, I haven't compared an implementation with that, so I agree we still need to do that. But I can kind of support CBOR, at least from that like theoretical side.
So one of the high-level choices that would be nice to hear opinions on now is self-describing versus schema. I definitely like the final performance of our built-in protobuf based on a schema. But when I look at the delta between the schema options that are presented here, say Avro, that we would like more realistically be able to achieve, and CBOR, I look and say, given supportability concerns about schema evolution, storing the schemas, communicating those schemas, getting clients to properly use the schemas to decode, I'm personally biased at this point towards self-describing. Is there general agreement on that, or is there more information someone thinks they need to make a choice? I guess most notably probably Joe, Mo, Jordan.
I will mention one thing that I don't think has been discussed yet, which is when you pick one of these, you can kind of mentally imagine a matrix of native types, CRDs, any other type in the Kubernetes system, and whether or not we would support this new protocol. With CBOR, because it's just a serialization layer, when you turn it on, you could turn it on for everything. You could have native types. If somebody wanted better than JSON but didn't have protobuf, they could switch to CBOR and get that benefit. If you go with something like Avro or Dynamic Proto, I don't know if we would ever turn that on for native types. Maybe we would. It seems more complicated. I think CBOR is very simple and clear in that way. It's just another protocol. Everybody gets it. It's just part of the wire protocol.
That makes sense to me as well. Mo?
In this discussion, are we purely talking, I guess maybe it wasn't clear to me, are we talking about how we store things in etcd, or are we also talking about how we do it on the wire, or both? Like that, I think I wasn't fully clear on where we throw away the JSON and put the CBOR. Is it in all the places with the JSON?
I think,
Yeah, I've been imagining both.
yeah.
Okay, so the idea would be is that relatively quickly over, like, technically, I guess, I don't know, 2 releases, you could switch the internals to start using CBOR, but externally it would be a choice that the client made via its accept encoding header. and presumably we would tell client Go to start using that as soon as we thought it made sense, I guess.
Yeah, when we store things in etcd, we store a little prefix that says what the contents of the rest of the bytes is. And so, if we went through a state where we had a mix of JSON and CBOR for CRD types, the system would understand that. It could read either, you would have to choose which one you prefer to write, which would presumably transition to CBOR over time, but the system already could support that. It would go pretty smooth.
And
Do we
yeah,
have
dynamic client
for
would,
JSON?
go ahead, sorry.
I was like, did we actually have a prefix for JSON? I thought it was literally just, does it start with a curly bracket? It must
That's
be
what-
JSON.
Yeah.
I mean, I know we have a prefix for proto. And I assume we would, I guess we permanently retain JSON support anyway, I guess. So I don't have to rewrite the etcd storage path test.
Yep.
Yeah, no, I mean, it sounds fine. I guess in the sense though, like if you make a decision today to do something like CBOR, you're not saying that we won't do a schema-based approach. It's more of, if there is a schema-based approach, it's going to have to be like really, really, really good to make it worth the effort.
It would have to be really, really, really good. I mean, I don't want you to have a false sense of what's likely here. If we do CBOR and we get numbers that approximate what's here for CBOR UGORG, convincing me that it's a good idea to support the code required to also manage schemas, it's going to take a lot.
Yeah, no, I think that's fair. Ben, when you looked at these implementations, by any chance, did you like, I don't know, just validate that they just don't use like unsafe everywhere to just like do questionable things?
How
Yeah,
questionable?
they're actually one of the CBOR implementations has unsafe implementations of certain things, but I have it disabled with a build tag. As far as I know, none of the others are doing anything unsafe. They're not importing unsafe.
Yeah, a lot of the high performance encoder decoders used to do unsafe casts to get around like map reallocation, but Go actually added some of the ability to reset maps into the standard reflect package. So hopefully, if that's all they were using it for, hopefully they don't need to do that anymore.
No, I am somewhat curious. Like, just, he said he has it off for the benchmark. If we did turn it on and decode got 50% faster,
I saw no discernible difference when I tried that.
okay. Well, that makes it easy then.
Yeah, I think we would want to look at like what the uses were for. I mean, we use unsafe casts in our conversion against internal external types that we have unit tests ensuring are identical. If they were using unsafe for something that we could verify was actually safe, that would be one consideration. But a lot of the uses I've seen are like unsafe or pointing at linkages to particular versions of internal Go functions for memory management. That's just nonsense. Like, we can't do that. So for the schema question, I've always been extremely skeptical about a storage serialization approach for custom resources that used a schema based on just how the whole world writes CRDs and evolves them. So I've always been in favor of something like CBOR, where it's self-describing and it's just a serialization layer. So if these benchmarks hold and we can like look at the edge cases and make sure that the correctness is where it needs to be, I like the idea of a self-describing CBOR implementation.
I do as well. I went through the mental exercise once of trying to think of like what you would have to do with CRDs if you wanted to use schemas. And my conclusion is you would basically have to write every schema that was ever used to write anything into storage, probably with a content addressable hash, and keep them all forever, and have no way to garbage collect them. It's kind of scary.
Right.
I had a question about compatibility.
Yeah, I can ask it. It is a bit more high level question. Sorry if you already it is obvious, answers is obvious. I didn't go to the details, but when we are talking about binary coding, so what happened if the CRs are changing over time, evolving, backward, forward compatibility, and other things about like data conversions might be more difficult. We are saying that we are decoding more than encoding, but in terms of like debugging, we need to encode, and then debugging might be more complex. So yeah, just want to know more in general why the whys are behind this binary encoding. Yeah.
So I think the point about schema evolution of CRDs is really critical, because if we use a self-describing encoding like CBOR or a similar encoding, basically all of the information that we're currently encoding today as JSON is also encoded, just in a more efficient form, for this whole class of encodings. I think the risks and potential complexity come when we talk about adopting a schema-based encoding, because in those cases, if you encode something with a current schema and then you lose that schema, or you aren't able to associate it with that object, then the data becomes useless to you. So we have to temper, I think, the potential theoretical benefits of having a schema in terms of smaller wire size and theoretically better performance, against those risks that I think that, as you said, come with schema changes. I'm sorry, was there a second part to the question?
I believe she also asked why use binary encoding, because it is going to hurt debugability. And as someone who tried to manually convert ProtoStream during one of Clayton's PRs, I can sympathize. So I think it's worth an answer.
Okay, yeah, it's a good question. At least with self-describing encodings, we can always translate them back to JSON. If we're talking about client requests, then we can always continue to serve JSON via content negotiation. But if we're looking at encoded objects, I think we would have to decode them back into JSON for debugging purposes. The raw bytes wouldn't be useful to a debugger, a human debugger.
But the benefit here, when you look at the benchmark, is looks like a 1/6, takes 1/6 the amount of time to encode to CBOR than it does to encode to JSON. So once you have that struct in memory in the QAPI server, you can encode it. It's 6 times faster, 6 times slower to use JSON. And so that's the benefit that we are chasing. That and memory utilization. If we can get lower memory utilization during the transform, then we will have lower peak memory utilization during lists and even during streaming watches when we get there.
Ben, at load, what % of an API server like CPU utilization is purely going to encoding, decoding? I think it's very high, but I'm curious just if you'd gotten to see just how high.
I don't have the data to back that up, but my intuition is the same as David, that anytime we're serving something from the watch cache, we're skipping a decode. So
yep.
It seems likely that we're doing more, potentially many more encodes than decodes, depending on the API load.
Yeah,
One
so like
question about
a
the zero-
benefit here is like very directly correlated to actual system performance as a whole. Sorry, Jordan, go ahead.
No, go ahead. The zero allocation encoding, I assume, is not just magic, but is using like a buffer pool or something like that.
Yes, the benchmark is providing the serializer with a pre-allocated buffer to use for the output.
Okay. I remember an issue that I think Daniel found last year where a buffer pool was like sort of gradually growing the shared buffers to the largest size that ever got written. So if most objects are like a couple kilobytes, but occasionally you need to serialize something that's like megabytes, like a full cluster-wide list of all instances. And then gradually, like the shared buffers grow to that max size and then get put back into the shared buffer and then are getting reused to serialize like 2 kilobyte things. That's something to keep an eye on. If we have control over the buffer pool, we might want to partition by size or do it in a way that we throw away things over a certain threshold, just so we don't like grow this shared pool. Anyway, it's implementation level stuff.
Yeah, it's a good point. In this case, the encoder itself isn't managing a buffer pool. It's just the benchmark is providing it to the call to encode. So these are really allocations are like incidental allocations that aren't part of the output bytes.
Okay.
Would it be useful to like track a list of things that we want to kind of check this library for? I feel it's different than the theoretical decision of whether or not we should use Seaboard, but just like to make sure that we properly vet this library.
Yes, you should keep a list.
I don't know, Ben, do you want to open an issue for that or something? We could dogpile on it. I don't know what the best way is.
Yes, I'll do that after this.
Okay, so before we run out of time, Ben, did you get what you needed from this conversation? Is there anything extra you want to address?
Yeah, I'm just last chance if anyone wants to strongly argue that that we need to see how fast we can make a schema-based encoding. I would like to hear that before we start digging into a self-describing encoding.
I think I already asked you to do that, and I think you gave it your best shot, and I think the results were underwhelming. Not a reflection on your work, just I am convinced that we don't need to.
Okay, as am I. Like, I'm pretty sure that, yes, with optimization effort, probably the Avro encode could become close or similar to what we're seeing on Seaboard. And the decode is better than Seaboard, but that decision comes with all of the baggage of managing schemas, which I don't know if we can make it better enough to justify that cost.
Oh, Ben, did you, it's been a while since I looked at this. At the time I looked, I like Seaboard the best. Did you look to see if there were any other protocols out there that we should seriously consider or anything like that?
I will now, since it sounds like we're pretty positive on self-describing encodings. I chose Seaboard due to compatibility and as an exemplar of like what a self-describing encoding might look like.
Sounds great.
If anyone thinks of anything else, please just reach out to me in any form and let me know. Thank you, everyone.
Thank you for bringing this to the meeting. And I think with that, we are done. I'm going to move Shane's topic to next time. Make sure to add your topics for the next meeting before the meeting, if you can. We'll see you next time, and I hope everybody has a good rest of your day and a good week. Thank you for joining.